Welcome back. In this video, I'm going to explore perpendicularity of a line and a plane. We're going to study two different kinds of perpendicularity. We have already studied perpendicular lines, a situation where lines are perpendicular to each other. Now we're going to also explore perpendicularity between a line and a plane. And I'm going to skip down past our first definition here, and I'm going to go to our first theorem. Our first theorem says, if a line is perpendicular to two distinct lines that lie in a plane and pass through its foot, then it is perpendicular to the plane. So if we have line RV here, and we say line RV is perpendicular to line VT, that would be one line, and line RV is perpendicular to line AB, a second line. Line RV is perpendicular to two distinct lines that lie in plane M, which would make RV perpendicular to plane M, because RV is perpendicular to VT, and RV is perpendicular to AV. So we've got a theorem. We'll use this as a reason and proof. If a line is perpendicular to two distinct lines that lie in a plane and pass through its foot, then it's perpendicular to the plane. So here we're establishing a line is perpendicular to a plane. So we have just established line RV is now perpendicular to plane M. So now that we have that, once we establish a line is perpendicular to a plane, then we can move back here to our definition. So we've established, or we're given now, that line RV is perpendicular to plane M. So there's a little bit of circular reasoning here because I'm using the same diagram, but the concepts are the same. If we can establish, or if we already know that a line is perpendicular to a plane, then we know it's going to be perpendicular to every line in the plane that passes through its foot. So even if I add more lines in the plane that pass through the foot, every one of these new lines that I draw is going to be perpendicular to RV. Because if a line is perpendicular to a plane, it's perpendicular to every line in the plane that passes through its foot. And this is really important, that it's every line in the plane and that passes through its foot. You've got to have both of those things. Okay? If we just say every line in the plane, well, here's another line in the plane, line PQ. It's in the plane, but it doesn't pass through the foot of RV. So just because it's in the plane doesn't mean it's perpendicular to RV. It's got to be in the plane and passing through its foot. And of course, it's just because it's perpendicular to the plane doesn't mean it's perpendicular to every line that passes through its foot. That's another common mistake. You might say, oh, it's perpendicular to every line that passes through its foot. Well, that's not necessarily the case. We might have a line like this, okay? That it's not perpendicular to, because this particular line isn't all in plane M. Line XY is not. It's coming through the plane, kind of like RV is. So these two lines, XY and RV, are not perpendicular because XY does not lie in the plane. So if a line is perpendicular to a plane, it's perpendicular to every line, not every line that passes through its foot, and not every line that's in the plane, but every line that's in the plane and passes through its foot. So you have to have both of those things. Every line in the plane and every line that passes through its foot. It's got to be the same. Okay? So you're going to want to memorize this. If a line is perpendicular to a plane, it's perpendicular to every line in the plane that passes through its foot. Let's take a look at a sample problem of perpendicularity to a plane. So we're given that PF is perpendicular to plane K. And we're given that PG is congruent to PH. I'm going to have to write that in my proof at some point. And we want to prove that angle G is congruent to angle H. Well, PF is perpendicular to plane K, which means that PF will also be perpendicular to GF, and PF is perpendicular to HF. And notice I write that separately. It's two different ones. So now we have our new long reason. If a line is perpendicular to a plane, then it is perpendicular to every line in the plane that passes through its foot. Our new reason and proof on a quiz or a test, that'll probably be worth about 4 points. So make sure you commit that to memory. All right. Step 3, I'm going to put my other given in, that PG is congruent to PH. And that is given. And it appears that I am working on proving these two triangles congruent by HL. This is the hypotenuse. So I need some right angles here. My perpendicular is going to do that. I probably could have done that right away in step 3. But I'll do that, take care of that right away now in step 4, where I have got angle PFG is right. Angle PFG and angle PFH are right. And that comes directly from step 2. Perpendicular segments form right angles. And PF is reflexive. Back up to my diagram here for you. Take a good look at that. So I've got reflexive. So here's my hypotenuse. PF is my leg. So my two triangles are congruent by HL. PGF is congruent to PHF. So triangle PGF is congruent to triangle PHF by HL, and that's steps 4, 3, 4, and 5, it looks like. And then angle G is going to be congruent to angle H by CPCTC. So there's an example of how we'll use our new information, our new concepts in a proof, and we'll have more practices with that. We'll use both this reason and establishing that a line is perpendicular to a plane. Okay, so this one you'll also have to memorize, and we'll practice that more when I see you in class.